Good morning, good afternoon, good evening, depending where you're joining us from. We are here to solve CTF number 12, and this is an exciting one. Um, just to remind you guys, this is part of Wizer CTF platform. This is the community version, so it's open to everyone. That's why we're also revealing the solutions here. This one, so every 2 weeks, we launch a new CTF, we retire a CTF, and basically we talk about it and show how to solve it. So this is one that was retired actually a while ago, and it's a very very interesting one. It happens in the wild. All the CTFs we're showing are things that we've seen or we've read about or that we know that are happening, and it's a great way to teach developers on how to spot those vulnerabilities and how to overcome them, and how an attacker thinks when they see your code and what you are missing when you write your code. Anyways, with that said, I'll let Itzik describe the CTF and how to resolve it.
Great, thank you, Gabby. Yeah, I think it's really important, and the reason is again, we're seeing it in the wild, but also that specific ones that we're showing, we're actually trying to condense it and look at the specific vulnerability. In this one, what we have is just a simple application, two endpoints taken from some application. Doesn't even matter what it is, and what it does, it has a one API endpoint that fetches some company assets from a certain folder. So the way it does that, it takes a company ID as an input, it finds it in the database and finds the matching folder name from which it's going to get all the asset names in that folder. In this case, assets are files. And so what it does to execute that request, it fetches the record from the database, gets the folder name, and then it runs this command, which is ls -1 and the folder name. Okay, so many times what we do is we find we find an OS capability that we want to use, and we just execute it as we want to use it. Okay, so that's one method. The other method, the other API endpoint, is API endpoint here that is called add asset folder. Add asset folder receives a company ID and a folder name, so that when I ask for it later, it will know which folder to get me the list for, right? So adding an asset folder receives a company ID and a folder name. And then it also sanitizes the folder, and I explain why in a second, and stores it in the database. So for next time, it inserts the database record with the company ID and the folder name. Okay? So that next time when I want to get the list of assets from that folder, I will use the first method, which is fetching those assets. However, the developer was thoughtful here somewhat and did think about the opportunity that could be very, very dangerous here of executing something outside of that format. So the developer thought, okay, I will create a method called sanitize folder, which will remove all the marks and characters that could be dangerous, like semicolon that I can concatenate commands, and or that I can get information output to flow into another process, and etc. and etc. Like and, which I want to enter multiple commands and so forth, bigger than, smaller than. So there are a lot of commands that allow us, or separators that allow us in a shell to actually execute multiple commands and kind of like trick the system to do what I wanted to do. So the developer felt good about this, but they also did something else in addition. Instead of just leaving it as is, they wanted to make sure that at the end there's slash assets, because the name of the folder has to end by slash assets, like company name ABC slash assets, company name CDE slash assets. So to make sure that it's there, if it's not there, then the developer added it, pushed it in there. Okay? So we have to consider that as well if we want to break into this system. So far, so good. Gabby, was it clear?
Yeah, so let me try to visualize it to the audience just to if I understand correctly. So imagine there is sort of like a photo app, and in the back end there is the name of my company or of myself, and there is somewhere on the server a folder that matches my name, for example, and inside that folder there are all the photos, right? So this is sort of what this app is doing. It's going to look up my name, go to the directory, find that folder, and in this case, do an ls command and fetch all the files
File names.
or the
Yep.
photos within that folder. So that's basically, if I had to sort of visualize what this app is doing. Is that correct?
Absolutely. Yeah. Yeah. It
Okay.
just does that through the database, not directly.
Yes.
It stores it and that, yeah.
It stores it in a
Exactly.
database. So,
Exactly.
and because the developer was using a system command to go over the files within the folder, in this case, an ls command, basically running on the server, the developer wanted to protect that, right? So he wanted to make sure that nobody's injecting any commands that are not supposed to be executed on the
Exactly.
server. What the
Mhm.
developer did was create, there's a function here that looks for all type of symbols and stuff that are sort of like an application firewall, almost trying to find things that are illegal in a sense, that it doesn't want those things to run, and also made sure that there is assets at the end. So whatever command it is, it will be slash assets, and it will probably break the command.
Mhm. Yep.
That's basically the what's going on here. So now we
Exactly.
need to figure out how to bypass the protections that the developer put in order to succeed running a command that will retrieve the file past WD.
Yep.
That's our mission.
Exactly. That's our goal. We're trying to read the past WD file just to show that we can do anything, right?
Yes.
We can do
Mhm.
that. We can read other files. We can do other things. Okay.
Okay.
So the way to solve it, let's jump straight into solution and then explain why it works. Okay.
Mhm.
So I'm going to take us to the Postman. Okay. And I'm obviously going to start by adding an asset folder because that's where my vulnerability is. And apparently the developer missed at least, there are multiple ways to solve it, by the way. This is only one of them. At least the ability to inject another command using dollar parentheses. When you have dollar parentheses, you can inject another command that happens in between multiple commands. So the hacker could use something like dollar parentheses and inject another command, which is in this case cat slash etc slash passwd to show the content of passwd. And then, not less important, since we want to make sure that the slash asset is not going to be on our way, what we can do is we can do hash slash asset, which is slash hash, refers to the rest as comment. So we're actually commenting out the assets. So the validation will still pass because it will find the assets at the end, although it's not going to be effective. So if I run this command and insert that record, and I made up a company ID which is valid because it is validated over there, I'm hitting send, and I'm getting a response from the API that I was able to insert the record. First of all, okay. Then once I've done that, but I don't know if it was sanitized or not, I need to take that ID and put it in here, right? So I already have it here, and then use the company assets API. And when I hit send, it fetches. So first of all, the ls command failed. You can see that ls -1 didn't work because this is not a valid command, right? It's not a valid folder name. However, in addition, I get can't access, but I get all the content of passwd. So I revealed the content of passwd, and effectively I got access, unauthorized access to this file.
Yeah. So yeah, this is, playing around with system calls through a web app is dangerous, because you
Yep.
think that you can do you're limited to what you know, but there are other things that you didn't think about, which I think comes to show the difference between the attacker mindset and the developer mindset.
Absolutely, absolutely. I think it's important to also see here, that there are two major takeaways, okay, that we can think of here. One is, first of all, as you mentioned, Gabby, which is really, really important to remember, executing OS command in our code is a bad practice because the shell command is so rich and it allows for so many different things that we can't really handle in a way like this. It's much better to use a library. So um, the first feedback, or the first takeaway that I would actually point on and focus on is replace all your OS command direct execution into libraries. In this case, we're using the ls command directly in the OS. We could have used fs for Node.js and use all the library and get the file names and list the file names that we have there. Sometimes we're just a little lazy. We want to see the list exactly as we see it when we use the command prompt. We already have it. We just use it. But it's a bad practice because the libraries protect us because they're very specific to what we want to achieve, and they won't allow other, external, malicious actors to play around and change stuff. So that's the first takeaway. The second takeaway is what the developers tried to do here was create their own sanitization. Okay. Again, I can't stress how important it is not to create our own custom sanitization, because this custom sanitization took into account a lot of options, but not everything. Imagine the shell is so rich. There are so many different bypasses and so many different ways to achieve the same thing, and other things that are kind of like tricky. Assuming that I can really find all those elements and remove them from a string is a big assumption. Okay. It's not impossible, but it's near impossible. And it's definitely not our focus as developers to think about that. So there are ways to sanitize. In this case, I would advocate against sanitization and just replacement of the library into a library. But if you're about to sanitize, be very careful what you're using to do that.
I think, one of the reasons is that sometimes you don't find what you want in the library exactly, and you know how to do it in command line.
Yep.
So you sort of take the risk, right? But you say, look, I'm going to mitigate it. So I'm going to take the risk and I'm going to mitigate it. I'm going to sanitize it myself. And
Hmm.
you think you're responsible.
Yep.
But this is the problem with, again, going back to the attacker mindset versus the developer mindset. When you write code, just being aware of the risk is one thing, but it also has to do with developers' risk appetite. And this is an example for that, where maybe they thought they handled it correctly, but they didn't. So when it comes to code, just do it the proper way. If you don't know, talk to your R&D manager or find a solution. Don't take risks when you're writing code, thinking that you mitigated them by writing another vulnerable code. So
Exactly. And
this is
not
something
many
that
people, I think it's really important to mention here, as exactly what you said, is not many people are aware of all the options that a shell command has. Like if you open the shell, there are so many tricks. Like people spend lifetime, writing different,
Mhm.
creative scripts. The shell is really complicated. It allows for a lot of options, and it's just too hard to find all
Yeah,
those options and say, oh yeah, I sanitized it. It's not enough.
yeah. So I think what I really like about this example is that they saw the risk, they tried to mitigate the risk, but they took the risk that it was an unnecessary risk.
Mhm.
So remember, when you're writing code, there are risks as well. So we have to build that behavior, code behavior, or whatever you want to call it, where people don't take unnecessary risk when they're writing the code, thinking they've mitigated it, because there's much more they don't know than they do know. So just follow the best practices and don't shortcut in order to deliver fast what you need, because you're under a lot of pressure.
Indeed.
Yeah, I
Absolutely.
think so. That's it. Any last words here regarding this challenge?
Maybe just to say that again, the walkthrough is here. Everything we talked about is here. The two takeaways are at the bottom. Replace all your commands to equivalent language in language libraries, and don't do your own custom sanitization. It's not a good practice. It's all in here with the walkthrough of how you solve it in here, and so forth. So you can read it anything is unclear, but it's out there.
And I think there's actually also another key takeaway. In this case, it's a short piece of code. So it's probably the same developer that did both. But in real life, you may have two different teams doing the API, and one didn't know that the other one allowed to save a vulnerability inside the database. So when they ran it, they were expecting something that is maybe sanitized. So, A, don't expect anything. And two, that communication that we spoke about last week, when we spoke about the collaboration between teams and sort of sharing what you're going to do when developing the code. People need to know.
Absolutely. Yeah, that's a good one.
Okay, cool. So that's it. And for people that are still with us here, if they want to try it out, it's again, these CTFs are public. It's under wizer-ctf.com. And you can just sign up for free, play around. There's a leaderboard. You can see on the right who are the top leaders right now. The people that solve the latest 6 active challenges the fastest are at the top. But because every other week we launch a new CTF, you always have an option to get on this leaderboard.
Right.
So yeah,
There's also the community here that you can chat with and can help you a lot with questions and so forth. So it's a really fun community, and a lot of really sophisticated and skilled people on there.
great. Okay, thank you very much, Itzik. Until next time, have a good day, and thank you for being with us. Bye bye.
Thank you. Bye bye.